Okay, so um, extra help on demand. Here we go. We're going to go all over factoring today. We're going to try to break the skill down into exactly what it is you're supposed to know, piece by piece by piece. And once you're well aware of these things, we're going to make sure that you are able to execute them. Obviously, this is everything you need to know about factoring, but it's not every example we could come up with. So it's a really good foundation for those who are still struggling with factoring on which to build. So the first thing we learn about factoring is that there are 5 key concepts. The first is using the greatest common factor. The second is the AM method. That's critical. The difference between two perfect squares is third. That's kind of methodical, mechanical. Fourth is factoring completely, which is a combination of the first 3 techniques. And then number 5 is the Plan B approach, which you only use when none of the others will work. So let's go with using the greatest common factor. Now, when it comes to the greatest common factor, what we are always looking to do is to find the biggest number and variable that divides into each. And you need to look for this. We like to say in class, what do you do before you cross the road? Look both ways. What do you do before you begin to factor? You always look for a greatest common factor. You have to do it every single time. So, as I look at this particular example, 3x squared plus 6x, what do they share in common? And what I notice is that there's a 3 in common and an x in common. So the correct answer is 3x times x plus 2. Now, the most important thing you can know about this is just do it. But check yourself by multiplying back. Now, here's an example that I've seen some kids do wrong in class. I've seen some kids do 3x times x plus 6. If you check yourself back, 3x times x is indeed 3x squared. We're good. But 3x times 6 is not 6x. It's 18x. Therefore, that must be wrong. And most kids, when they do that, would instantly realize that they had to change the 6 to a 2. Because then, again, 3x times x is 3x squared, still a check there. 3x times 2 is 6x. So that works perfectly. Okay, let's take a look at this second one. What do they share in common? I hope that you notice that they share a 4 this time, and also an x again. So I'm going to pull out my 4 and my x. I always choose the least amount of any variable present. Okay? Now, let's put in what we think the right answer is. Let's say that we think, just for argument's sake, the answer is x plus 3. Now let's distribute back. Does 4x times x equal 4x squared? Yes. Does 4x times positive 3 equal positive 12x? No. But you usually see exactly what your mistake is. You do 90 to 99% of the time if you do the quick mental check. 4x times x is 4x squared. 4x times negative 3 is negative 12x. So the correct answer is 4x times x minus 3. Now in class we've been doing a lot that are binomials like these. But sometimes you get common factors in trinomials. In this case, what do they share in common? It's worth noting first of something they don't share in common. They don't share any variables in common. So they just share a 2 in common, which would give me n squared plus 4n minus 12. And then I could distribute back. And this is actually a bad example to have chosen because I could also then factor the trinomial, and I don't want to do that yet. So we'll just stop here. 2 times n squared is 2n squared, 2 times 4n is 8n, 2 times negative 12 is negative 24. So this is not a good example to have chosen. I apologize. For now, we're just going to stop here. In the real world, we would keep going. But that's the common factor pulled out. So first type of factoring, using the greatest common factor. Okay, if you still struggle with that, go back, listen to it again, see where you get. Okay, next up, the AM method. This is critical, super critical. Probably the most common factoring that you will be asked to do in this particular class. By AM, we put an A over the middle term and an M at the end. And one of the bad things about AM is you kind of think that you start with the A. You don't. You start with the M. What we ask ourselves, A and M stand for add and multiply. I'll use an X for multiply. You start with the M. Always start with the M. Oh, actually, the first thing I do is look for a common factor, and there is none. When there's no common factor, that's when I go to AM. And when I look here, I ask myself, well, since I have to multiply out to 8, how can I do that? I can do 4 and 2. I can do -4 and -2. I can do 1 and 8. I can do -1 and -8. Now, some kids are not good at their times tables. If they're not good at the times tables, what you're going to do is you're going to go into your calculator, and you're going to type in y equals, and then whatever the last number is, in this case 8, and then you're going to do divided by x. And then you're going to go into table. And when you look at the table with x, y, these values will be in the table. There'll also be some values in there with decimals. Just ignore the decimal values. It means it doesn't go in evenly. But if you find the ones with without decimals, which is exactly what you'll find is this list, then you ask yourself, out of those possibilities, which ones add to 6? And in this case, it's +4 and +2. So there are my factors, x plus 4 times x plus 2. And if I double distribute back, x times x is x squared, x times 2 is 2x, 4 times x is 4x, and 4 times 2 is 8, which gives me 2x and 4x makes 6x, what I started with. So the factors are x plus 4 times x plus 2. Now we go to the next one. X squared minus 10x plus 24. And again, AM. How can I multiply out to 24 and add to -10? And what I come up with is -6 and -4, which means the factors are x minus 6 times x minus 4. Now, let's just say that you had difficulty with that. What can you do to find those factors? Get your graphing calculator out. If you do not have a graphing calculator at home, there's no excuse. Now, they are $100, and that's a lot of money. But almost everyone I know has either a smartphone or an iPad or a Kindle or maybe even a smartphone and an iPad. I prefer an iPad because it's bigger, it's easier to see, but you could do it on your smartphone. If you go to the App Store, you can download Desmos Graphing Calculator for free. And it's not as good as the one you use at school, but it's about 80 or 90% as good, and it will greatly help you with this. Okay? If I do my quick mental check here, x times x is x squared, x times -4 is -4x, -6 times x is -6x, and -6 times -4 is +24. Notice that's a -10x in the middle, which is what I wanted. So this is my factor. Okay? Next up, AM again. AM. How many ways can I multiply out to 20 and add up to a +9? Now, let's just say you did it wrong. Let's say you did c minus 5 times c minus 4. When you do the quick mental check, you'll see that you have -5c's and -4c's add up to -9c's. That's why we always like to do that quick mental check. And then you say, oh, sloppy mistake, should have been positives. And the correct answer is c plus 5 times c plus 4. Okay? Now, what I suggest you do is you pause this tape for a couple of minutes and try the next 3, and then when you're done with the next 3, turn it back on again, and I will give you the correct answers. Okay, so I assume you have now turned the tape back on, and I want two numbers that will multiply out to -8, add up to -2. That would be n minus 4 times n plus 2. If you multiply back, you get what you're looking for. If you reverse the signs, if you did this, you would come up with +2n in the middle. This is wrong. Listen, generally, as long as it's a 1n squared, this will always work. This is the sign of the bigger number, right here. Whatever sign's in front of the middle term is the sign of the bigger number. So here, it's going to be b plus 5 and b minus 2. I think it's pretty easy for kids to realize that the 10 and the 3 have to get you 5 and 2. But sometimes they mess up the positives and the negatives. Once again, as long as the coefficient in front of the b squared is 1, the a in front of the b squared, so to speak, is 1, then this will be the sign of the bigger number. So it's b plus 5 times b minus 2. If you do a quick mental check, you will get b squared plus, minus 2b plus 5b adds up to +3b minus 10. And in this last case, before we even start, can I ask you, is there a common factor? No. So what's the sign of the bigger number going to be since it's 1m squared? Sign of the bigger number will be positive. So it's m plus 12, m minus 2. All right, so there are some good examples. Now listen, there's an infinite number of these things you could go over. What you're supposed to realize now is always check yourself back again. If you don't know the factors that will get you the last term, you go to, right here, calculator, y equals, you take whatever that last number is. On the last one it was negative 24, and you do divided by x. That will give you the table and all the possible values. Remember, if you see a decimal, ignore them. Just check the ones that are not decimals. Okay, so that's the AM method. That's the one that takes, I think, the longest to teach. And practice that one until you're great at it, because it's a big help. Now, the next one, the difference of two perfect squares. This is kind of methodical. First off, notice that in all of these cases, they're binomials. And that makes sense because it's the difference. Difference means minus. Notice everything is a minus sign here. Of two, that's why it's a binomial, perfect squares. And in perfect squares, this only works if you can square root both of them. If you can't square root both of them, like if I gave you a squared minus 3, you can't do this because you can't find the square root of 3. Square root of 3 is imperfect. It doesn't break down to a rational whole number. This would then become a plus 5, a minus 5. Now, let me talk to you a little bit about why this works. It works because even though we don't bother to write it, in the middle here is a plus 0a. And when I multiply back, a times a is a squared. A times negative 5 is negative 5a's. 5 times a is 5a's. Negative 5a's and 5a's add up to nothing, 0 a's. And that is technically what we have in the middle. We just don't bother writing it. And positive 5 times negative 5 is negative 25. So I recognize the square root situation, the difference of two perfect squares. B plus 2, B minus 2. If I multiply back, it will check, but notice, square root of B squared, B, square root of 4, 2. Next one, C squared minus 81. C plus 9, C minus 9. Square root of C squared is C, square root of 81 is 9. Now sometimes they get a little bit more challenging and they put numbers and letters in both of them. Don't get scared, just square root both. 10d plus 7e, 10d minus 7e. Let me give you another quick one to do. 9x squared minus 64y squared. Again, I see the difference and I can square root both of them. 3x plus 8y. What's the other one? 3x minus 8y. So those are many, many examples of the difference of two perfect squares. And I would say those three cases, finding the greatest common factor, knowing the AM technique, and the difference of two perfect squares. If you can master all of those, the next two types, which would be considered the more involved types, are just based on those three steps. And if you can do those three steps, you can do everything else that's involved. So, factor completely. Now listen, this is what I told you in class. I said, growing up in my house, if my parents called me Bud or Robert or Pal, I knew everything was okay. Bobby, I knew all was okay. But if I heard the phrase Robert Carl Lindquist Jr., it was butt whooping time. That means the beatings were about to begin. Likewise, if you see the phrase factor completely, that means 2 steps. And you must learn to recognize that. It means you need to factor twice to get the same, or to get the correct answer. And if you don't factor twice, it's not going to work. So for instance, let's take a look at this first one. You might say, hey, gee, I could do difference of two perfect squares, but you focus in on that word completely. You do not let that word leave your sight, and you say to yourself, common factor, common factor. What is my GCF? In this case, the GCF is 4. Factor it out, x squared minus 25. Now, that's my first step of factoring. Remember, factor completely means what? 2 steps. Could be more, but you don't really see more. X plus 5, x minus 5. That's my second step. Step 1, step 2. What I did was I took the difference of two perfect squares here, broke it down, x plus 5, x minus 4. Next, p to the 4th minus 81. Okay, looks like the difference of two perfect squares to me. Let's see how it goes. P squared plus 9, p squared what? Minus, look at that, I can factor that one. The p squared plus 9 stays the same. There is no sum of two perfect squares. But this guy could become p plus 3, p minus 3. And my answer is all of these. You have to include all of the factors. The 4, the x plus 5, the x minus 5. The p squared plus 9, the p plus 3, the p minus 3. Now, I take a look at the next one. These guys share a 2 in common. N squared minus 2n plus 1. So now I need to factor the trinomial that remains, and I can do that. 2 times n minus 1 times n minus 1, which if I wanted to, I could say 2 times n minus 1 squared. Either one of these, this guy or this guy, would be considered correct. Okay? And last but not least, if you haven't paused the tape already, try this one again. What do they share in common? They share a 3. And that leaves me with x squared plus 4x minus 5. I can factor my trinomial. 3 times x squared plus, x plus 5 times x minus 1. Notice again, all three factors are included. 2 steps. Step 1, step 2. Factor completely. 2 steps. Make sure you get it done. Okay. That's the 4th level. The 5th and final level is here. Plan B. To do Plan B, what I do is I notice right away that it has a lead coefficient other than 1. When it has a lead coefficient other than 1, like on the previous examples, I look to factor that out. Can I pull a 2 out of these? No, I cannot. I cannot pull an x out of these. So at this point, you might say, uh-oh, spaghetti-o, I'm stuck. But the truth is, Plan B will get you out of your dilemma. I'm going to take the 2, and I'm going to multiply it by the 15 in the end. Now, that gives me x squared minus 7x minus 30. At that point in time, or at this point in time, were I a student in class, I'd be saying, what the heck, Mr. Linquist? You can't just go changing the question. You change the question, you're not getting the same answer. Bear with me here. Factor this using an, okay? And you're going to get x minus 10 times x plus 3. Okay, right? Because you're going to add up to negative 7 there. But here's the thing. Since I multiplied by 2 here, I have to balance that out by dividing by 2. And once you get to this step, you must evaluate whether or not you can simplify each of these things. For example, 10 over 2 right here can be simplified. This becomes x minus 5. And if you cannot simplify, you go to the elementary school technique. I take the 2, I multiply it by the x plus 3. 2x plus 3. And these 2 are my factors, and if you double distribute and multiply back, you'll see that it does work. Okay? All right. Let's go to the next one here. 3x squared minus 20x minus 7. I'm looking for that common factor. I don't see it. So I'm going to multiply by 3 here. That gives me x squared minus 20x minus 21. That's pretty easy to factor. And I am going pretty quickly here because I'm supposed to be on hall duty. I did ask for permission to do this and I received it, but I'm going to want to go back out to hall duty in just a few minutes. So I'm going fairly quick. But you should realize from the AM section we just did that if you're stuck on this, you type in y equals negative 21 divided by x, and then you go to table on your calculator and you look for anywhere where there are 2 whole numbers next to each other. In this case, you would see negative 21 and positive 1 and go, ah, I could have had a V8. No, you'll say, oh, I can add up to negative 20 there, so it works. Okay? So, but since I multiplied by 3 here, I need to balance it out, divide back in by 3. On the left, it simplifies to x minus 7. On the right, it does not, so I'm going to elementary school it. 3x plus 1. Like converting, somewhat like converting to a improper fraction. Kind of like that, but you don't leave the 3 on the bottom. take a look at the next one. When I look at the next one, I see no common factor. I had hopes for the 4 there, but 4 doesn't go into 15. So plan B, x squared plus 4x minus 60. Then I'm going to factor this. I get x plus 10 times x minus 6. Then I have to, don't forget, divide back in by that 4. And I get, well, this is interesting. I get x plus 5 over 2. And in this case, I get x minus 3 over 2. So I've simplified both of them, but they don't come out to whole numbers. That's okay. I'll elementary school both of them. This is 2x plus 5, and this is 2x minus 3. And surely, if you double distribute back, you'll get the answer that you started with. Okay, everything that we're ever going to need to know about factoring for our grade level is right here in front of you. This is extra help on demand. I hope it benefited those of you who are still struggling with this stuff. I think you should do very, very well. So I hope you do a great job with this, and I hope you finally know how to do all of this work at home, and you can now factor beautifully. Have yourself a great and wonderful day. Oh, and the next one, we will do one more by the end of the week, and it'll be on how to do quadratic equations.